I always seem to forget. Okay, so it's recording. So yes, it will be uploaded to YouTube later, that recording. And at the end of this presentation, we provide a survey. So please check out that survey because this is what helps us determine what we're going to talk about next. It's how we curate content. And again, lastly, I'll just kind of briefly mention who we are. We are an application security company. We're based out of Herndon, Virginia. We were founded in 2009. We provide web and mobile assessments, penetration tests, help you secure your development processes. We do training both in person as well as our on-demand interactive training platform. We perform AWS consulting, so we're an AWS consulting partner. And we provide a range of security services around code security in general. So things like fixing your code for you with our code remediation service. And we just do a whole host of things here. So we're going to get started. I'm going to get right into it. So this is titled Keeping Up Modern Software Security. We are really briefly going to walk through a few things here. So an example of sort of this tooling and these stacks that we're going to be talking about, we're going to walk through a few breaches here. So Datadog was hacked, and essentially they're a cloud provider, so they store credentials for cloud environments. So when they were breached, what they noticed was that someone was trying to use their client's credentials to access the AWS environment. As well as they noticed some issues with their production infrastructure. So, thing to take away, it's a provider you're using for your cloud environment. If they're breached, think about what impact that has for you. In terms of, I think everybody's seen the rash of ransomware that's going around. So, there's this rash where MongoDB databases left open out on the internet where their data was actually being stolen. And then a ransom note was being left, and then you'd have to go through them and pay some amount of money to actually get your data back. This one's interesting. Basically, it's the same concept, but instead of actually giving you your data back, somebody's asking if this meeting had started yet. Is anybody having any issues here? No? Okay. Okay. Yep. Just that one person. All right. So in this instance, they didn't actually give you your data back. They just deleted it and then made you think they had it and had you pay for it. So that was an interesting one. And again, so that's Redis servers that were hacked. Say hacked, they were pretty much just left open. This is always an interesting example. I always like to bring it up because like one example of a company that actually just went out of business after they were hacked, Codespaces. So their AWS environment was hacked, and then the interesting thing here is that whatever they backed up was backed up in that same AWS environment. So not too great. This is a talk Chris Gates and I did at RSA on DevOps tooling and sort of hacking it. And I think the thing that I want to kind of bring up there is that we talked a lot about breaking into misconfigured or just flat out, default credential, kind of left that there out there on the internet, these types of things with various DevOps tools. And we also give a lot of ways to kind of get some visibility into that. So I like to bring up the talk because I think it's useful and is a complementary to this talk. And I'm going to hand it over to Jack to let him talk about himself.
So I'm Jack Mannino. I'm the CEO at nVisium. So I get to do a bit of R&D these days. My coworkers definitely do try to keep me away from a computer and running a company. But when they turn their backs and let me near a computer, I'm doing a lot of development these days in Scala, using the Play framework. And so when we talk about just some of the things we look to secure, we're also talking from the perspective of software we build and just kind of tricks we've learned along the way.
Excuse me. So I'm the CTO here over at nVisium. Talked a lot about, as I said before, DevOps security. one of the things on there that I have for a list of conferences was, or a list of places I've spoken, was CERN. And I thought that that was interesting, mainly because, when I went there, it was an amazing opportunity. It was this great experience, but with all of the crazy, amazing things that they're doing, trying to solve mysteries of the universe, at the end of the day, they had the same issues that we see time and time again with, they think about it. They have a lot of data. They have a lot of technology that's new that security has to get out in front of to do something useful with that data. And actually, from the conference, and it's listed there, Insomniac, Dr. Stefan Luters, he has a talk where he walks through all of their tool chains, and I highly suggest looking through it. He's the director of security over there at CERN. But it's interesting to just see that everybody has the same sort of issues everywhere. So this talk's not just about testing. We want to talk about some solutions. We obviously love technology. I mean, Jack definitely loves technology. I can tell you that. We love this technology. We want you to use it, but we want you to use it securely and also use it to your benefit as a security person. And as you saw, this stuff can have disastrous consequences, and they are completely avoidable. Let's get into challenges. Basically, we're going to talk where this talk's broken down to microservices first, cloud and infrastructure as code. So that's cloud and then infrastructure as code. They kind of go hand in hand in that section. And then we talk about development processes and just a general lack of tooling around some of the way things have sort of sped up. So there's a little bit of evil. It's a little bit of that where we talk about challenges and we talk about the ramifications. And of course, there's a lot of nice too. We're going to get into some solutions here. So I'm going to hand it over to Jack. He's going to talk about microservices.
So microservices are pretty popular. You read about them a lot. Everybody seems to want to be building and decomposing their applications into microservices. So traditionally, we've built big monolithic applications. So we've built these monstrous Spring applications, Struts applications, and pick another Java framework where you've built a ginormous application. Nowadays, we seem to build smaller applications where we like to make them independent of everything else, different deployments, different stacks, and if one of these services failed, it doesn't bring down the full architecture. So this is basically at a really high level microservices. So if you're familiar with things like service-oriented architecture, microservices kind of breaks it down a little bit further, gets rid of a lot of the dependencies between services. So here's Martin Fowler's definition. So if you look up anything on architectural patterns, you'll find Martin Fowler's probably wrote about it extensively. The biggest thing to take away from here, though, and I can say this from experience, is that everybody has their own opinion on what microservices are. And this is very similar to other things like DevOps and Agile that they have definitions and then they have very loose translations. From experience, I've found that microservices tend to range from very pure implementations where every service has its own database, its own cache, its own plumbing and nuts and bolts. Whereas you kind of find that people will group things by business focus, and they'll build systems and boundaries around those in reality. So we'll take a little bit of a look at how people actually implement microservices. So one of the things you'll kind of read and hear and people will say, microservices simplify everything. I hate to be the bearer of bad news, but this is completely wrong. Microservices certainly have a lot of upside to the pattern. But at the same time, when we use microservices, we're also adding a bit of complexity because instead of one big application that talks to one Oracle database, we might have dozens of services that are going to talk to different places to get data from, different caches, different analytics platforms. You name it, your data is going in a million different directions these days. Here's a good example, right? So once upon a time, you had this big application. So it's that big pile of monolithic code on the left-hand side. Nowadays, so imagine that big monolithic application was, banking.com, right? And then somebody came in and said, you know what, we want to go microservices, right? So bankingapplication.com is now broken into bankingapplication.com /payments, order details, etc., right? So each of those particular functions is essentially abstracted away as a service behind the scenes. So if you're coming from, things like service-oriented architecture background, you're saying, well, what's different? We just kind of take basically breaking out those dependencies a little bit further.
I just want to point out, this is my favorite slide, Jack. This is my favorite slide.
This is Ken's favorite slide for some reason.
Love the visual.
So here's an example. If you think of a service like Amazon, right, there's a lot of different things you can do, from ordering things to reading reviews to tracking where your shipments are, your payment history. So applications like this and really big platforms are a good place to implement microservices, right? So each of those particular services is going to essentially be developed independently of others, right? So you can actually bring your own stack, right? So one of those services can be written in Go, one of those services can be written in Java, right? And so you can have multiple stacks. Essentially everything's running in its own process, which is very different than a monolithic application where you're going to run that essentially in one big process, right? Big fundamental difference in how you distribute things in a microservice architecture. And here's just a really simple example of what you could expect. One thing we'll talk about a little bit more is API gateway. This is a fundamental pattern that you'll see a lot in microservices. In this example here, though, we have an API gateway where all authentication is happening. So if you're coming into this from a mobile device, a single-page application, maybe with, like, for example, an Angular front end, a smart device that is, looking up information. Hey, where is the yogurt? I notice we're running low on yogurt. Can I poll and see when that's coming? So I can send you an alert in the morning. It says, hey, yogurt's not here yet. Sorry. Behind the scenes, though, one of the things that should be interesting is how all of those services are actually connected together via some form of message queue, which in this case we use Apache Kafka as an example. So you'll see this used pretty heavily where services aren't necessarily hard-coded to each other as dependencies, but they may use some common, basically, way call it almost like a bus, way to basically send events between services when things happen. So one place you will see some type of coupling is maybe with a message queue like Kafka. But what this means essentially is that the example is the account service can publish an event, and all of those other services can consume only the relevant events that they care about. So you kind of see where the the simplicity you see on the front end at the API gateway is one unified experience, right, with defined routes. And behind the scenes, you have these really complex relationships, right, where these things may be tied together via messaging, but each place has its own independent place to store and persist data, which can range from not that interesting to super duper, important, HIPAA data used by, somebody treating oncology patients, right? So depending on that data, you really care about where it moves inside of the architecture. So step one, though, in a microservice world, API hygiene, you should basically use it, right? So anyone that's selling you a new scanner, for example, is lying, right? So cross-service microservice injection is not real, and anybody selling you tools is completely making it up. So basically things like cross-site scripting, SQL injection, right? These are no-brainer things that we've solved elsewhere. One consideration in the microservice world, so just kind of going back a slide, so imagine your application totally protects, so your service is doing a great job of protecting against something like SQL injection, but then you potentially pass data over a message queue, another service consumes it, doesn't actually do the same preparing of a statement or something like that to protect against an injection, and now you may have SQL injection in a completely different service. So this is a place where, in a monolithic world, you essentially know what the sink is for that data, right? So think of a traditional MVC application. You basically send something, it hits an endpoint, The sink is, a database interpreter, right? It runs SQL. It either runs it safely or not, but you're able to basically trace the input of that all the way to basically the sink, right? So from source to sink and determine where it hits that database. Well, once you pass that over basically, a message queue or a commit log, you have no guarantee that the other service and consumer is going to handle that safely, right? So, things that you may be on the hook to be responsible for, some type of sanity check on data, input and validation, right? Well, input validation doesn't actually solve things like SQL injection. It can make it a little bit harder to get untrusted data into the system, right? So as you're building your applications, it is important to think about how is the data that my application is basically consuming and basically putting out going to be handled by another application, and what can I do to ensure that that data propagates safely throughout the architecture. So one place that things do change quite a bit around authentication and authorization. With regards to microservices, you have some very careful considerations you need to take. But fortunately, some really good tools out there to take advantage of. In this slide here, we just kind of talk a little bit more about where that data goes. And compared to a monolithic application, it can go to a lot of different places, right? Especially, if anybody's worked with data science teams, and anybody ever seen anything like, what they'll do with, notebooks tied to Apache Spark, right? So we can run these big, data analysis jobs, and like we can leave the data and results for somebody to interpret. But if you're basically creating an application that's generating this data that's consumed in this way, you have no control over that life cycle, right? So it is very important to think about the data life cycle in this situation. So we talked about the fact that there's good tools out there to handle authentication in a sane way. So AWS provides their own API gateway. This is an architectural pattern that there are implementations of. So AWS has an implementation, Azure has an implementation, and there's also open source tools like Kong, which is built on top of Nginx, that allow you to achieve similar capabilities if you're not tied to a specific platform or infrastructure up in the cloud. And what essentially the API gateway pattern allows is to abstract authentication from your services. So each one of your microservices doesn't necessarily have to be concerned with authentication, but rather it can trust that the gateway, which obviously should have proper trust relationships between, handled that and authenticated the user, and any identity that's passed that service from the gateway can be used to determine what that user is allowed to do. So at a high level, the API gateway handles things like authentication, whether that's through credentials, whether that's through SAML or other forms of federation. And it also handles things like API tokens. So if you're using like API tokens to authenticate users on each request, the API gateway completely abstracts your services from some of the nitty-gritty details of how to handle that. At my day job, we actually do use a similar setup for our own architecture, using AWS's Cognito service and API gateway. So Cognito basically handles user pools, handling things like user attributes, authentication, credentials, MFA, turning it on and on, so on and so forth. If you're building an application and you don't want to build all that, it's a great way to do it.
How many times have we seen somebody roll their own custom single sign-on or whatever that basically equates to the same thing and screw it up? I mean, that's why we have jobs, right?
Absolutely. I'm a security guy that dabbles with, development. So I know there's a lot of better developers out there. Unfortunately, a lot of them work at Amazon and they build some really cool ways to do this. And there's very close feature parity for things like in Azure. Us, we're an AWS shop. We build software on AWS, so we certainly dog food it. So obviously our talks have a very AWS theme for that reason. But things, for example, like JWT, so JSON Web Tokens, API Gateway and Cognito also make this a first-class citizen. So you can do things, for example, with those JWT claims to pass that information, service to service, to actually figure out what entitlements users have to your respective microservices. And using this particular implementation works similarly on Azure as well with their cloud functions, but you can also basically implement Lambda pretty closely with this. So as requests come in, you can run essentially Lambda functions to do things, whether that's transforms on data, checking things like roles, etc. But you basically have an entire layer that you can integrate Lambda with to do really fine-grained logic behind the scenes. So if you're looking for a setup that's going to allow you to do authentication, authorization in a sane way, I really recommend this. We also use Swagger to document our APIs. If you're not using something like Swagger, I'd certainly recommend giving it a test. But Swagger essentially makes it easy to document your APIs and obviously pump those into other tools to ingest that and understand your API. It's also really nice, in a microservice world to publish stuff like that, knowing that you may have different teams that need to figure out how to consume data. Being able to publish a nice API spec with Swagger is really, really, really nice, and developers will love it if they're not already using it.
I don't know, security people love it. We love it.
And but you shouldn't expose it to the web if you think stuff in there is really, really sensitive, right? If you intend to publish an API, then by all means publish it to the web. But if you don't, then maybe you restrict that route to internal, something like that. But once you do get past the API gateway, now you have the ability to pass information about the user into your services, right? So, just anything you'd commonly associate with like a user table. And you could also extend with additional attributes as well. Beyond that, you can use things like Lambda to, do more fine-grained lookups on roles, licensing, entitlements to different services. But this is just basically an approach we found that works well when trying to implement these things in a microservice world. So there's things you can implement at a high level, but at the end, when you get into really fine-grained things like resource level access controls, you should be thinking about checking for those things at the microservice level. Sometimes I've found just from experience that's too high level or too low level an operation to abstract. So things like resource level. Maybe you want to think about those at the service level. But what about authorization between services? So we talk about, for example, what is the user allowed to do? Are they allowed to hit certain functions, right? And so from the perspective of API hygiene and doing access control on the user stuff, that's, something that people think about. But what we don't sometimes think about is how are those relationships enacted between services. So before we talked a little bit about Kafka. So Kafka is used to set up basically publish and subscribe relationships between services. So if one service is going to produce a message every time it gets something about a credit card being received, another service essentially wants to consume that, right? So in this example, if the other service that's consuming it isn't maybe of a trusted set, you have a problem, right? And especially if you handle PCI data, you shouldn't be doing stuff like this to begin with. It's certainly shunned and frowned upon in this world. But this is totally a boo-boo, right? So in this scenario, we didn't think about who would actually consume that, right? And the threat model here is like maybe we had 2 or 3 services and we didn't think about, the 4th and 5th services and who would actually be standing those up. So maybe it was somebody on the data science team. They said, oh, we're really interested about all the data that basically flows through here. So we want to find more intelligent ways to basically digest that, right? So now you have another team who realized they had access to a data feed. They stood up another microservice. Maybe they're doing some kind of stream processing where they're ingesting the data, doing stuff. And you totally didn't think about that your data was going to end up there, right? So when you're building out these services, and especially if you begin to, say we want to broadcast some sensitive data between services, think about these things at the beginning, right? So make it as fine-grained as possible, and then let somebody complain about a service not being able to get that data, and you explicitly add services to be able to consume, right? But this is just an example of more places where your data is going to spin, and relationships you need to think about out of the gate. So another area we see a lot of interesting things and a lot of actually really good work being done is around sharing secrets between services. So, if we're basically creating, a monolithic web application, we know there's a couple places, maybe it's, in a couple config files, a YAML file, an XML file, a conf file, right? Where we have, hard-coded keys, which we don't want to do that. But nonetheless, there's a couple places, and usually we have a better solution using some type of key management solution, just anything but hard-coding credentials, right? So some of the things we know about how we build software and mistakes, well, welcome to the container world. We brought them with us. So talking about containers and serverless, they really do go hand in hand with microservices. You're not generally seeing a lot of people, building a microservice architecture on, basically raw servers these days. So bad ideas are hard coding things into your Docker files, right? So credentials, other secrets, but unfortunately people do this. Environment variables are another thing that's used. We'll show an example of that in a minute. But when you pass secrets with environment variables, it's potentially available to all the processes in the container and not limited to only a few, which is the least restrictive way you can implement that. So here's one example. You can 9 times out of 10, I can promise you, avoid doing stuff like this. And probably use a better password than password2, but nonetheless, this is pretty common where people will create a Docker file, they'll hard code their password, their secrets, and then they'll commit it to GitHub, right? And then somebody's account gets compromised, and somebody has those secrets, and they laterally spread and steal everything and burn the house down, right? So you definitely don't want this to be the case of the kingdom. So there's better ways to do it than that. This is a slightly better way to do it, but still not the greatest way. So if you're basically spinning up a container with Docker run and passing in environment variables, you can do this, and you can maybe do it slightly more securely than if you were hard coding it. But again, when you do it this way, you still do run the risk of every process being able to read it. And additionally, think of when you're running these commands, you may very well have different dashboards, doing analytics and obviously giving you history. Well, now you have those plain text credentials that are going to be visible to anyone with access there, as well as potentially persistent cached in logs. And who knows where those logs end up, right? So in this perspective, we're just continuing to try to limit the scope where those secrets are going to travel. Fortunately, we've gotten a lot better in the past year. So if you're using any of these tools, whether it's Kubernetes, which we use and we're huge fans of, Docker and Docker Swarm, or DCOS from Mesosphere. So each of these solutions does have pretty much first-class ways of doing secrets management, and Docker's really, really leading the way right now with the things they're doing, especially a lot of the recent stuff they announced at Docker Hub, and they're doing DockerCon. They're doing some awesome stuff. Here's an example, though, if you're using something like Kubernetes, where you can actually pass secrets in to containers at runtime, and you can also pass it in, for example, to multiple services within a pod, basically, right? So the way Kubernetes does it is it'll actually distribute it in a file system, essentially, store that's available to any of those group services. So what you can do as a layer beyond that is additional permissions with regards to individual users and processes and groups on those systems that can actually consume those secrets. So kind of a little bit of Linux food combined with the native features, but you can do better secrets management than just basically allowing everything to read those secrets. And but while Kubernetes does a good job, unfortunately, it's not perfect. I've been doing security for over 15 years, and when we invent perfect security, I'll be unemployed. We haven't done it yet. And Kubernetes does some really good stuff, but still totally some things to think about. One example is your credentials are still going to be stored in plain text. So obviously that's the box that you pretty much want to, that master node, you really, really want to restrict ever exposing that to the web. So if you're spinning up, Kubernetes cluster on AWS, you really want to make sure Things like security groups around that is really, really tight. The last thing you want is somebody busting into that box and getting all those secrets from one place. So while it does, solve some of the issues, it does still have one place that is, your single point of failure. If somebody gets in there, they're going to be pretty deep into your architecture. There's also tools like Vault that are out there. So you see Vault used pretty extensively with things like AWS's key management service. Vault has really good integrations there. Vault was used pretty heavily. It still is used pretty heavily, but as more of the orchestration platforms start offering first-class secrets management support of their own, I'd imagine Vault maybe falls out of favor with some of those. But nonetheless, it's super useful, and if you don't have a good way to do secrets management now, take a look at Vault. And rotate your keys maybe. So using tools like KMS, Vault, and having centralized ways to rotate cryptographic keys, service credentials, and the like. It is easier than ever, and in fact, as you have more and more services that you maybe are going to roll out, using one infrastructure is code solution, you have good security opportunities to do these things that were really hard before, where maybe you had to coordinate between 10 different teams to do those things on a quarterly basis or annual basis, right? So now you have tools that allow you to do these things centrally, and I'd recommend leaning on those heavily to do some of these good security hygiene practices as you go.
Okay, so before I get into it, I did want to answer a couple questions here. One was, will these slides be available? Usually I do tell everyone at the beginning, but yeah, they'll be available later, as well as the video itself. And then there's another question here, Jack. I think this is for you, and it says Ansible Vault or HashiCorp Vault? Question mark.
HashiCorp.
HashiCorp. That's from our friend Justin. So that is. Are there any other questions? Just taking a brief breather for a second here. All right. Then I'll just jump right into it. So code is infrastructure and the cloud. Obviously, code is now infrastructure, right? That's what we're here to talk about. One of the things we're here to talk about in terms of developers pushing infrastructure with their code. What that now introduces is a situation where a developer, on the machine that they're developing, in the environments where they're pushing code, those environments hold the keys to the kingdom. They hold the configurations, and that's essentially infrastructure. And this is a fairly new-ish territory for security teams, right? So if you have immature practices, it can sort of lead to massive issues and business disruption. I think Jack's taking a picture here. Here's a few logos here of various services that provide what we're talking about. Terraform, Ansible, CloudFormation. So the old process of doing this, of pushing infrastructure, you got your programmer, and she submits a request to stand up a server or do something in the data center. Network security guy gives her the thumbs up, and then nothing happens. The request is denied or whatever, right? The new process looks like this. Do what you want. I'm just kidding. So all jokes aside, what it really means is now you've got developers pushing infrastructure, and that equals a shift in the responsibility, right? So now you've got software developers who are essentially, they control the whole stack, so they're responsible for all of that. And I'm not saying this holds true for everybody, but in a lot of situations, this is essentially removed those years of learned experience, those traditional procedures built out of hardship or just lessons learned. That those policies go away. So it's this interesting paradigm, and in terms of security teams, they're really trying to catch up, right? Because now you've got to keep an inventory of these assets, and you have to monitor them. The security tooling is very limited. No matter how much someone slaps a DevOps sticker on their product, doesn't necessarily mean it actually helps do anything in a DevOps environment, right? And now security people also have to go and understand the technology itself, right? Because they're responsible for the hardening, for the configurations. They're responsible for helping you secure this as a software developer. So they have to obviously understand what they're working with. And your architecture may now be a GitHub repo, right? So what that means is you have to keep track of who's actually committing code and who has access to commit code. And then those peer reviews or those code reviews, before merge, they become incredibly important. Here's an example of some infrastructure as code, right? So left and right, two different configs, both for AWS, but essentially you can see that we've got like our VPC information, Elastic Load Balancer, that's what ELB is, just different information that tells, AWS, hey, or, basically a DCOS one on the left for AWS, basically says, here's what we're going to spin up. And that becomes actual boxes with potentially with vulnerabilities on them. So again, with this shift in responsibility, and we talked a lot about this, Chris and I, in the DevOps Redux talks, but and here's a link to the RSA conference one. Basically, you have to really focus on securing and monitoring developer machines, right? They have to be protected. It's not just their machines. It's, hey, where are you posting your code for help to? What are the practices that you're using every day? These things become incredibly important. But what I'd also say is that training between security and development becomes incredibly important, because as security tries to keep up and understand the new tools that development wants to push into production, that learning curve and understanding that technology could be easily reduced by cross training between the two departments. But at the end of the day, concerns are still pretty standard. Access control. Make sure nobody can just punch right through the network perimeter. Secure baselines, meaning secure baseline configuration images. So if you're taking advantage of virtualization, we'll have virtualized machines that are already, they come pre-configured, pre-secured almost, right? And then patching. But here's the thing, antivirus patching, I'm really not sure what you would do for serverless, right? So Jack, I don't know if you have any thoughts on that, but I'm pretty sure there's nothing out there to help out with serverless. I'm talking ephemeral machines that have a lifespan of like 60 milliseconds or whatever. So, and the last piece is, securely maintain secrets, sort of what Jack was alluding to and talking about. Luckily, nobody actually puts their keys out there on the internet. Okay, and it's weird on a webinar. I can't hear you laughing, so if you think that's funny, I wouldn't know. But this is an example of me just searching GitHub for an AWS credential file and finding some access keys over and over again. And some of that in source code as well, different applications. So these are, again, access keys that give you the ability to get into somebody's AWS environment. And while we're talking about the cloud, and by the way, I made this picture myself. I'm very proud of it. I called
Very
it
proud.
Very proud of it.
Very proud.
Cloudy McDevil face. And this is sort of what security thinks of the cloud. Basically, there are three primary services that folks are using: AWS, Google Cloud, and Azure. When we talk to people, when we're on the road, when we talk to our customers, when we get questions, a lot of it seems to be focused around AWS. I don't have any pretty charts of the market share, but we get a lot of AWS. So that's what we're going to talk about as an example. But it's still, the concepts apply everywhere. So here are the challenges. elasticity. So you've got machines you've got clusters that are spinning up new machines up and down. Things are changing. The speed of infrastructure deployments. So in like a minute, you could have infrastructure built. It could go from code committed to a repository to an actual set of machines, right? And I know for security people, that's kind of a difficult setup to work with. Access control, right? You've got all these boxes now. You need to secure access to them, and then the externally accessible data center. I do want to talk about that just for a second. Think about that. I mean, I love the cloud. I love using the cloud. It's great. And what I should note though is that this is an externally accessible data center. So use it, but be aware that your credentials you're using to sign in, the API keys you're using, anything that's misconfigured, and we're going to talk a little bit about that, anything that's misconfigured on there, any little hole you expose ends up being something that gives somebody access to this externally accessible data center. Give me 1 second here while I get a drink. Okay, so sorry. Common attack patterns that we see: abusing misconfigured services, hosting vulnerable systems. So when I talk about abusing configured services, that could be RDS, that could be S3, that could be whatever. And again, this holds true for Azure or Google Cloud. Hosting vulnerable systems. So if you have a machine that's unpatched or has ports that are open, and maybe it's hosting a web application that has command injection or remote code execution, that's a vulnerable system. And then leaked or exposed keys. And again, going back to those screenshots I showed you a few back with the people committing code. I mean, that happens all the time. People committing code or dot files or whatever with keys. It's actually so prevalent that AWS itself has a bot that goes out and looks for it and tries to keep up by deactivating those keys when they find them. All right, so this is an example of a misconfigured service here with S3. So this is a bucket that has permissions where any authenticated user can access that bucket. So this is Chris Gates was performing some enumeration of open buckets and basically did an LS on one of those open buckets and had access to it. And again, that's because any authenticated user, not just your AWS environment, any AWS environment's authenticated user had access. S3 is just one example. Others are RDS, Elasticache. I mean, honestly, there are a lot of services on Amazon, so you can find examples for pretty much all of them. Here's an example of using Shodan. Shodan is the Google for hackers, and this is just to illustrate that by simple search on there, Elasticache shows you open Elasticache instances. And then if you ever want to look for compromised instances or examples of compromised instances, EC2 instances on AWS, just go to Google. And it's so prevalent that someone had built a tool to automate actually using machines that are compromised to pivot throughout the AWS network. There's some links and some information there. How that looks is basically once they're on the EC2 machine, they browse to this IP. It's available on all EC2 instances, and they grab some temporary security credentials and use those to pivot based on the permissions of those credentials. And this is an example of Chris using a tool to actually use those credentials and then see what services he has access to with the tool. Sorry, this is me running Chris's tool rather. Okay, so this is just a couple examples. So this was a QR thread. I've talked about this before, but when you go through and look at the entries on this, it's just people that leaked their key and they had overnight huge bill. And so many people on this forum said I had that issue. Another one is just to somebody who outsourced their Rails development to a developer overseas. That developer committed code to GitHub publicly. And then, their bill went through the roof and their account was compromised. Okay, so solutions. Let's walk through some solutions. Sorry, getting this to click here. All right, so I really like the talks from Jason Chan and Ryan Huber. Jason Chan's from Netflix and Ryan Huber at Slack. What these talks basically come down to is, they use a lot of automation to kind of get out of the way, but also empower and help developers. And I think one of the interesting things is using things like chat. But both of them talk about using chat ops, right? So going into like Slack or HipChat or whatever, and having a bot that looks for requests or alerts on something, but using the ability of the real time kind of response to chat, and also being able to send some commands through chat to actually help out and keep things secure. So for example, if you were to use like Netflix Hub Commander, which allows you to do some things on GitHub, and is secured by Duo, two-factor authentication, you could, in theory, say, hey, here's a template for code for code that represents infrastructure. Here's a template, a CloudFormation template or whatever it may be. It's in this code base. I want to be alerted when somebody wants to change it. And I also want to essentially have the ability to pretty quickly review the change and go ahead and either approve or deny it. So those talks that I just mentioned here kind of walk you through the concept, and as well as they talk about some of their open source code that can help you with that. So to summarize with code as infrastructure, keep your baselines secure, and as well as your templates. Use automation. Request a review of templates to merge templates into code base, and then I'm going to move on to AWS solutions. Sorry. So there's three things I always talk about: hardening, monitoring, and disaster recovery. And all of the details are at this slide here. So we're going to talk about this at a high level pretty quickly. So IAM, so you need to harden IAM, individual services themselves, and then secure baselines. For the root account usage, only use it when you have to. Always enable multi-factor authentication, which is essentially two-factor authentication on both the web and API. And then audit your IAM users policies. I used to audit your IAM user policies. I used to actually give you code to do this, but now Amazon, this like link here, they made it really easy to actually review what individual user has access to. It used to be really painful. Now it's not. And then Jason Chan in that talk from earlier talks about Repo Man. It still hasn't gone public, but it's an interesting concept. Check it out in that video. In terms of services hardening, there's no silver bullet here or guide I can really point you to. This one helps a little bit, this AWS security best practices, and it really comes down to encrypting everything, both in transit and at rest, restricting network level access control, limiting access both to users as well as roles and things like that. I mean, it's all common sense kind of stuff. What I really like is Alex Lucas at AWS reInvent last year gave a talk, and I was there. It was a really great talk on what you see here, which is automating security, both creation of baseline for your images, as well as like testing code as it goes out the door. And we're going to talk about that and actually show you an example of that and point to how to do that. But and then just checking application access controls. So three services I always talk about: CloudWatch, CloudTrail, and Config. These are built into AWS and are free. And again, I think the other two platforms have their own services for this. CloudTrail, essentially this diagram on the right, what you see is anytime you do something, if it's through the web console or CLI, it doesn't matter. It comes in for a collection into CloudTrail, and then CloudWatch can do something with it. Events, they've got events and metrics, and it can basically help you analyze whatever is going on, whatever's stored in CloudTrail. And then there's Config, which is essentially asset and change tracking. At the end of the day, and by the way, there's a link to code there that actually gives you the ability to do what you see here. But at the end of the day, this is what we're trying to use these services for, to get real-time notifications on what exactly is happening in our environment. We have to monitor our cloud environment. For disaster recovery, there's really only two options I've come up with so far. Well, I say but this is from talking to people. So one of them is, and I really like this idea, which was to use a service like Glacier to back up to another AWS account, which has extremely limited access. Only like a couple people should be able to access this environment, or a few people. security people, preferably, maybe an operational person. But either way, it's extremely limited in access. And then the other option is just to manually download and store on site or store somewhere else. Yeah, there's no real, I haven't seen a great option. If anybody else has, feel free to either put it in chat and I'll bring it up later or at the end of this. But ultimately, do not back AWS up to the same AWS account.
And I might add, number 2 might be pretty hard if you have a couple petabytes of data.
Yeah.
But fortunately, Amazon does send a truck out, I think.
They'll come send a truck your way. Yep. So, summary, utilize DevOps practices such as chat apps. You leverage the CI. I'm going to show an example of that. And utilize built-in services like to monitor and alert, strengthen your image, review configuration changes, and just ultimately harden everything against compromise. Use automation. All right, so now we're getting into dev methodology. So the fairly typical standard that we see is that someone submits code to a repository. Maybe there's a peer review of the new code, some unit tests run, and boom, it's in production. Yay, everybody's happy. Problems. It's impossible for a human to review every excerpt of code manually before it reaches production, at least in a normal environment, unless you're only pushing a very small amount of code a very few amount of times a day. In terms of tracking down bugs, so finding bugs is hard, but then you've got the other flip side of that, which is bug resolution tracking, which is incredibly rough. And then you've got a whole other thing with, every time you add a library to an application to do something, now you've got a software library that you have to inventory and keep track of. The old school tooling that was available was you collect a zip file, you try to compile it, then you go back to the developer and you say, hey, that didn't compile, I need all the code. Then you beg for mercy because none of this will compile, but then maybe eventually compiles. Then you have 500,000 findings from this tool. You cry a little. You got to take a little break. You tell development, "Hey, I'll get back to you in 3 weeks." Then you hope and pray that you can get back to them in 3 weeks. That's the old way it used to work, and that was sort of the waterfall methodology, right? So let's talk about a couple solutions here. So one is unit tests. Unit tests are typically thought of as a security thing, right? Or sorry, a developer thing that they do, but they can be security centric. And here's an example of running some security unit tests against an application. Here's an example of one of those unit tests. So really all it does, and it's very simple, is it just goes to this dashboard page. And if it doesn't receive a 302, then it knows, hey, I've either got an issue where forceful browsing, I'm not being redirected, whatever the case is. Or maybe there's a 404 or something along those lines. Either way, there's an issue. Here's another example of doing something a little bit more DevOps-y, I guess we'll say. So this is for you Rails folks out there, folks who like to take pictures of their cats and, all that fun stuff. I'm kind of like making fun of myself, by the way, because Jack always gives me garbage for being a Rubyist.
He does own a cat.
Yeah, I do own 2 cats, actually. So on the left, there's the build spec YAML file. And really all you can see here is that at the bottom, it runs Brakeman. And Brakeman's a great tool. I like the open source version. The pro version's great too. Offers some advantages. But in terms of, running Brakeman in code pipeline, which is essentially exactly what it sounds like. It's pushing code. It's a pipeline for pushing code. You can use Code Build. It's a service offered by AWS. This link walks you through actually setting all this up. So at the end of the day, when you've set it all up, here's what you've got. Code pipeline pulls from GitHub. It detects a change or somewhere else. They've got a few options for repositories. But if it sees a change on GitHub, it pulls the code. It runs its tests from within AWS Code Build service. And that's a security test for us. It's Brakeman. And then at the end of the day, it pushes that code into whatever environment makes sense, production, staging, etc. All right, so in summary, same thing we've kind of been reiterating here, which is use some of the same tech and processes that your developers are. And automation's great, but I think specifically here with security testing, you need to have a way to resolve bugs. Whether that's a process or some tooling or a combination of both, you need to have a way to resolve bugs. All right, overall summary. I don't know if you want to take this over for a second while I drink some water.
Sure. So application inventory, know what you own. So once upon a time, that was really easy when you racked and stacked servers and all of that. And nowadays, single button, and you can deploy a full infrastructure, right? You can spin up new containers, you can spin down containers, you can pull untrusted containers, you can pull things from a trusted baseline, right? So it actually gets harder than ever to do inventory management. We work with some organizations that have crazy amounts of AWS accounts, and they have to correlate data literally between dozens and dozens of accounts, and then spread that out between AWS cloud, between Google's cloud and Azure, and it gets incredibly hard nowadays to do proper software inventory, right? Because once upon a time we built monolithic applications. Automation is our friend. Automation shouldn't be the end all of everything, but at the same time, there's just simply no way to get eyes on as much code as probably moving through your environment these days. So it is important to basically think of a good blended strategy between where is automation paramount and where can we inject good human processes around things like peer reviews, right? Where another developer is going to look it over another developer's shoulders, right? So there's things you're going to do well with automation. There's things you're going to do better with people. It is important and to understand where certain things are going to do better. Obviously, we have more and more data to kind of digest now, so it is important to find security dashboards that integrate well with development tools. Giving your developers a spreadsheet and basically saying that's how we're going to collaborate is just not going to work, right? We have webhooks for almost anything these days, whether that's integrating with Slack and other tools, being able to push things directly to and from Jira, right? We should be focused on integrating with the same tools that we're using for development if we're going to have any success at making security fit into that.
All right, so that's sort of the end there. Sorry, I'm trying to get this thing to work. Doesn't want to. Okay, so that's the end. I know we've thrown a lot out there in a not so short amount of time. But yeah, so if you have questions, we'll open it up now, and we'll stick around for as long as anyone has questions. Again, if you had to walk away, I know this is an hour long, no problem. That'll be up on YouTube. So yeah, I'm going to go ahead and pause here and open it up for questions from everyone. Okay, so we got a question here. It says, are there modern architectures where it makes sense for microservices to authenticate each other? Or is anything past the API gateway considered trusted and message queuing controls access to messages and data?
So we still should be doing some type of authentication between services, right? So you'll find, depending on the tool, some may support things like pre-shared keys, right? Some, different tools may support things like, mutual TLS between endpoints, right? So it is very important to be able to also authenticate services, right? So, things we didn't get into, behind the scenes with regards to, things like message level integrity, right? Signing things, from services to have some kind of authentication built into the messages. If this was 2 hours, then I could probably dig a little bit deeper into some of those strategies.
Yeah, I think we were trying to tackle a lot. So yeah, I think there are definitely things you can do beyond the API gateway, like Jack said, protecting microservices messages between microservices. I don't know if that answers your question. That was Kevin. If there's more follow up, feel free to ask. Trying to think, is there anything else that we didn't cover? I think we went over. I mean, there was a lot to throw at everybody. All right. Well, let me see if there are any raised hands Don't see any raised hands. That was the only question that I see. So let's see here. I'm going to give it another few seconds here, and then I'll probably cut this out. And I think we hit right at about an hour, so all good. Thanks everyone for attending. By the way, we really appreciate your time. We know you may not have the time, so we really do appreciate you. Sorry, there is another question here, but we still appreciate your time. Thanks for coming. Anyone that had to leave. Any advice on helping secure nested environments where developers have set up virtual ESX hosts and run tools such as Console from HashiCorp for DNS discovery, etc.? Ooh, so let's see. Any advice on helping secure nested environments? Oh, wow. Gosh, that sounds from HashiCorp for DNS. That sounds like a pretty specific case. I'm not sure how often do you come across that very often.
So I guess if I'm trying to understand, then they have. Is there? I guess are you giving like contractors like jump boxes to different resources? I'm not totally understanding. I guess.
Sounds like they're kind of just running tools. I'll paste that on there. Maybe we should. Here, hold on. Sorry. Yeah. Okay, we can ask. Okay, we can answer that offline. I think it's that might require a little bit more.
Okay. I didn't see it. Yeah. So there's, I guess, a bit to that one, right? So I mean, depending on, I guess, like the services and where they're coming in from. But again, that's potentially a place you could restrict that with a centralized. I guess not understanding. I guess like I mean, very familiar with the tech, but I guess just not understanding. I guess everything about the architecture. So short of I guess giving you an answer that's not going to make sense. I
told him I gave him an email address to so we can talk offline about it since it sounds pretty highly specific. Kind of hard to answer that one. Alrighty, well, again, thank you for your time. I'm going to end the chat. Everyone have a great day. And feel free to, please fill out the survey. Sorry, if you're still here, please fill out the survey. It only takes like a minute or less, and it helps us. Thank you. All right. Appreciate it. Bye. If I can figure out how to turn this thing off. There we go.